Active mass refers to the source of gravitational fields, as described in Newtonian gravity or general relativity. It is the mass responsible for generating gravitational forces. Passive mass refers to the property of an object that determines how it responds to gravitational forces. It is the gravitational charge that interacts with the gravitational field. Inertial mass refers to the property of an object that resists acceleration when a force is applied, as described by Newton's second law, F equals ma. Weak equivalence principle states that the inertial mass and passive gravitational mass of an object are equivalent. This principle is foundational to Einstein's theory of general relativity and has been experimentally verified to high precision. Jacques Sarfatti critiques claims of inertial mass reduction by Puthoff and Pais, suggesting that such claims violate energy conservation laws, E equals mc squared, and lack empirical evidence. Sarfatti's critique aligns with scientific principles, emphasizing coherence and resonance dynamics, which could be testable under the weak equivalence principle framework. It is noted that the Navy has been involved in testing the feasibility of the claims made in the patents, such as those related to manipulating the quantum vacuum and achieving macroscopic quantum coherence. However, it notes that no working prototypes or public results have been produced from these efforts. This lack of experimental evidence and practical demonstration adds to skepticism about the claims, which critics argue resemble science fiction rather than substantiated science. Feynman emphasizes that scientific claims must be testable and falsifiable to be considered valid. In the context of the document, the mechanisms described in the patents, for example, vibrating cavities, electromagnetic fields, are theoretically testable, but the impractical energy requirements and lack of experimental evidence make testing infeasible. While the claims are falsifiable in principle, the absence of feasible test conditions undermines their scientific credibility. Key takeaway: Puthoff and Pais's claims about inertial mass reduction and the Pais effect lack empirical evidence, practical feasibility, and mathematical support, making them speculative and leaning toward pseudoscience. Sarfatti's critique, grounded in Fröhlich condensate physics and testable mechanisms, is more scientifically robust. Keep skepticism sharp and focus on evidence-driven approaches.